Let me start recording. Here we go. All right, so arithmetic sequences. This will be what we're going over today. So a sequence is an ordered list of numbers. You can see like 3, 5, 7, 21, 16, 11, 6, 1, 2, 4, 8. So these are all sequences. And each number in a sequence is called a term. So real quick, can someone tell me what the interval between these numbers are? Okay, so for the first one, you just plus 2. Second one, minus 5. For the third one, you multiply by 2. So the first two are arithmetic sequences, and the last one isn't.
Okay, what is a pattern? Sequences often have patterns that can help us predict what the next term in the sequence can be. Like in the previous slide, we saw the difference between each terms, the interval between each term helped us determine what the next term in the sequence will be. So for example, using the sequence from the previous slide, we can see that the pattern is to add 2 to get to the next term. See, like 3 plus 2 is 5, 5 plus 2 is 7. Can someone just or unmute and just say the next term in the sequence? And these ellipses, these 3 dots, and that the sequence can be infinitely extended. Like it can be extended forever unless otherwise indicated. So this just tells us that the sequence goes on. It doesn't just stop after the few terms. Okay. And yeah, the next term in the sequence would be 7 plus 2, which is 9. Yeah. So an arithmetic sequences are a pattern of numbers that increase or decrease at a constant amount. It can be addition or subtraction. So it can grow or get smaller over time. So in this case, in this lower left corner, we can see an arithmetic sequence that increases by 2 each time. So each term increases by 2. So the first term just refers to the number in the order. So the first term is 3. We add 2 to get to the second term, which is 5, and then 5 plus 2, 7, which is a third term, and fourth term is 9, which is 7 plus 2. And then the 3 dots, like I mentioned before, it just tells us that the sequence goes on forever, even though we just wrote 4 terms down. And just a disclaimer, term, element, member, they all mean the same thing. They all refer to numbers in the sequence. So we're now gonna look at arithmetic sequence formula. So the formula for finding arithmetic sequence equations and to find an arithmetic sequence. So an arithmetic sequence, the thing that defines an arithmetic sequence and sets it apart from other sequences is that it has a common difference, a common interval between each term. So the formula for the nth term can mean anything, like it can be any number. Like if you're looking for the 43rd term, n equals 43. So the formula for the nth term is an equals a. So an just means the nth term, and then a plus n minus 1 times d. So a is the first term of the sequence, a number 1. Like in the previous sequence, a was 3 because that was the first term of the sequence. So a plus n minus 1, and n is the nth term of the sequence. So if I'm trying to find the 43rd term, I would do n minus 1, which is 42, and then times d, and d is the common difference. So if I was trying to find the 43rd term of the sequence we talked about before, the 43rd term would equal 3 plus n minus 1. So n is n minus 2, n minus 1 is 42 times d, so times 2. So that would be 3 plus 42 times 2. So that's 3 plus 84. Yeah, so 80. Oh, wait, that's not correct. Okay, but anyways, we would just use that for finding any term in a sequence.
So let's go ahead and do some examples relating to this new equation that we have and applying it to a problem. So for this problem, we're going to determine the 8th term in the sequence. So our sequence is 3, 5, 7, 9, and so on. So there are two different ways to do this. The first way is to use the original equation that Mahati has given you. AN equals A plus N minus 1 times D. If you plug in the numbers properly, you will get 17. Remember that 3 is the first term, N, which is the term we're trying to find, so 8, and then the common difference is 2, so that means 3 plus parentheses 8 minus 1 parentheses times 2, and that will equal 17. The second way to do it is just continue the sequence as if you were writing each of them out. So you can say 9, then you add 2, 11, that's the 5th term. Add another 2, that's the 6th term, and you continue on to get 17. Both will give you the same example, or the same answer. Now, some problems may ask you to find the sum of the first 10 terms, 11 terms, or something along the lines of that. So to help you find those two, we would have given you two equations. You'll notice that it's circled down here. I won't read them to you, but because you can probably guess what the different variables mean. So why are there two formulas? So this is because in the first formula, you need to use the difference and the term number. But the second formula, you are most likely going to use this if you have been given the last number in the sequence and the first number in the sequence. Therefore, to determine the sum of the terms, that case, you can just use the second formula. Are there any questions in terms of these two equations for this? Because this is a little bit confusing. Please at least give us like a no in the chat so we know you're live and you guys are participating. Nothing? Okay, nothing? Okay, then that's fine. So go ahead and write those two equations down. You can come back to it later. We're going to go ahead and move on. So let's determine the sum of the first 10 terms in the sequence we had earlier. 3, 5, 7, 9, continue on. So for this one, we want to use the first equation, this Sn equals n over 2, 2a plus n minus 1d. So let's go ahead and find what each of the variables are supposed to be. So for n, we want to use 10 because we're trying to use the first 10 terms. Then a is our first term, is so 3, and then we found the difference already as 2. So when we plug it in, we get 10 over 2 times 2 times 3 plus 10 minus 1 times 2. And I'm sure you know how to do PEMDAS, and we're just going to go ahead and say the answer is 120. Now, let's go ahead and try to use the second equation now. So the question is asking, determine the sum of the first 12 terms in a sequence where the first term is 3 and the last term is 25. So we have been given the first term and the last term. So we're going to use the second equation, which is n over 2 times a plus a to the term of n. When you see an like this, where the n is like a little small one at the very bottom, that's referring to the nth term, the value of the nth term. So we're going to go ahead and plug in the numbers of each equation, First 12 terms, we've given 12. That's the number of terms that we're supposed to be using. Our first term is 3, and an is, of course, the 12th term, or the last term in this case, so 25. We're going to go ahead and plug it in, and you get 168. Now, are there any questions about these sum formulas? If there isn't within the next couple minutes, then we're going to assume you guys are okay.
Okay, so also I want to point out something, the difference between an equation and a series. So usually we have the sequence 3, 5, 7, right? So the difference between an equation and a series. So some people might see this as okay, y equals 2x plus 3, right? Does this seem familiar? linear formula. And you can see when x is 0, that's when y is 3. When x equals 1, that's when y is 5, so on. So it's like a line like this. So the difference mainly is that a sequence, well, there's only integer numbers of terms, right? You have a first term, second term. There's like not really a half term. So that means, so it would be, if you see this, is more like kind of like dotted. And then for an equation, it means anything. It's a straight line. That means anything, like even decimals work. Like decimals are also covered by this equation. Another difference is that when we're doing equation, when x equals 0, that's when y equals 3. But for terms, the first number that comes out is the first term. So a common misconception will just be plugging in 1 for the first term and getting 5. So that's a common misconception. But one way that lots of sequences are written are that it's if n equals, so we have let's use a as the number equals 2n minus 1 plus 3. So this is a way to differentiate between a equation and a sequence, and that's by doing the minus 1. So you can say, oh, first term, that's n, and you still get the right number, which is 3. Are there any questions? Okay, so I'm just gonna say that a reminder that next week there will be no class before we get started on our classwork. So okay, I'm going to put this in the chat. This is the This is the link to the problems for arithmetic sequences. So if you get on it, you can make a copy. You make a copy and start working on it directly. And I'll also post the same thing on Google Classroom.
Justin, the recording.
All right, I'm